Sorry.
I'm just starting the recording. Hello everyone, welcome back to the daily Leetcode practice. Okay, and we'll be going through the 3 problems, easy, medium, hard for today. Please share my screen and get started. The first problem for today, so actually I'm not sure if people have noticed it or not, but we have changed a bit of organization for the daily basis. Instead of easy, medium, hard on daily basis, you might get some medium, some hard, and some easy combination, different variants of those combinations. So for today, we have 2 medium and 1 hard problem in our bucket. Starting with the first problem for today, which is from the medium bucket. So we have to find the maximum area of an island, and we are given a 2D array. And for the definition of an island, what they say is any ones that are connected to each other in the 4 directions, which is essentially horizontally left and right and vertically up and down. Okay, and for those kind of connections, you have to find what is the maximum island that can be created by those ones. Okay, and if there is no island, you just have to return 0 as the maximum area. Any ideas? Anyone has tried this problem?
Yeah, it's like how we go for finding the island. We have a question earlier that how find whether there is an island or not, and you need to go to 4 directions. There we search for an island, and like how many islands are there. Here we need to find the area of that island, and which is the max one. I think what I did using a depth first search over here, and like in depth first search, I am going for each island and counting how many ones in that on that island, and then comparing with the and giving them and take I have taken the max variable where I have taken the like whatever the max area of that island will be my answer.
Okay, and what will be the time complexity and space complexity?
The time complexity is like n square it would be, because I am traversing all the each cell. Yeah, I'm traversing each cell.
And the space complexity?
Space complexity is I have taken one array which is a visited node, like visited array, because I need to mark whether that cell is visited or not. So space complexity is also like m into n.
Is there a way we can reduce the space complexity?
Yeah, we can like the cell which we are visiting, we can mark it like a -1 or something, and then
or we can mark it 0 itself.
Yeah, or we can mark it 0 itself. But the only thing is, the only thing is if the 0 we are traversing, and if there is a cell which has a 0, oh yeah, so we are not counting that part. So yeah, 0 would also, yeah, we are counting one. So yeah, 0 would also make sense.
Sorry, but how making that 0 will have that answer?
Sorry, could you repeat again?
Like I understood that we need to have a another like n cross m row cross column matrix, which uh, like have the visited nodes true or
Mhm.
false. But how simply changing the values to zero within the same matrix will help to find the maximum area? Like this,
So that is not
I,
helping you find the maximum area, that is helping you to reduce the space complexity. Instead of having another array, which will tell you whether that node needs to be traversed or not, I am using the same matrix, and anytime I have just visited one node, let's assume I have visited this node, okay, and I know once I have
mm-hmm,
visited this node, I don't want it to visit again, even in my iteration or anyone else. Like it can come from the left of this or top of this also, right? I don't want this to be revisited again. So what I'll make it will make, I'll make it inaccessible for everyone. I'll mark it zero. Now any forward iteration or DFS, whatever is going on, it will not ever come back to this. But as it is DFS, the bottommost or the leaf node, when you reach the last node, it will automatically have the maximum count. Because you will already
okay,
increment that count once when you are exit, right? We are just making it inaccessible in any future iterations of DFS.
okay.
Is it going to be the recursive DFS or iterative DFS?
Anything. You can use any, whatever you're comfortable with.
Mhm. Yeah, but I did with recursive DFS.
I think for iterative, you might have to use a stack.
Stack, yes.
So recursion already has that inbuilt, so you need not.
It's my
Do
you know,
we
try to
have,
compare if we do the DFS is would be better BFS, like breadth first search would be better.
In this case, they both are going to give you same complexity, but DFS will be better because anytime, any tree that you are, or any island that you are looking, you always have to iterate through all the nodes in that. It's not the minimum that you have to find. DFS is usually better when you have to find the first short point where you are, you have to stop early in a tree. But in this case, you have to anyway traverse to the entire area to find that it's count of area, right?
Mm-hmm.
It's not just few nodes that you can cover and then stop. BFS usually helps you if you want to stop at specific level.
In terms of the memory usage, like if we use the queue versus stack, if we use DFS, would that the stack might grow bigger than if we use a queue level by level?
Correct. For a very, very large tree, BFS makes more sense, but here we are already given that it's just going to be 50 cross 50. For a very huge tree, yes, DFS, if it's very height is very long, then probably it will, have a very huge stack space, but even then, the BFS will have a high usage, probably less than what stack is going to use. But yes, both of them will be, in case of a very balanced tree, we have a very balanced tree, then probably DFS will give you less space as compared to BFS. BFS at that time in max will be n-1 nodes. That's the last level nodes. And DFS in that case, maximum stack space would be log of n.
Would suppose we have this matrix is all of them are one, okay, all the value are one. Would that the stack space would be like, I try to figure this maximum of stack would be m time n time m.
That will be n square, yes.
Okay.
Because what will happen is it will suppose start from the right side, it will keep going right, and then when it reaches here, it will suppose start moving down. So it will move in actually spiral fashion.
I see. Okay.
And then it will just end point. Yeah, good question. I think on the space complexity for this kind of scenario, BFS and DFS. Any other approach on this one? Or any question on the space and time complexity for BFS and DFS that we just discussed? Okay, I'm assuming there's no question. We'll move on to the next